Would you like to level up your obby creation with neat mechanics, like ropes and bridges that are interactive and respond to player movement? If so, this video is for you. My name's Dan. Let's create something. Okay, so we're in a new project. We might just take a top-down view of this, move our base plate away, and create a part. I'll set this just to be one little cube. We'll set its position to be 0, 0, 0, 0. There we are. And we'll copy it. Move this fella over here so that its position is going to be 10, 0, 0. So we know that this part and this part are exactly 10 apart. It's going to be, this one is ours. It's going to be the start of our bridge. This one is the end. Okay. Now, let's that view around. Now, if we have to divide this into nice equal segments, we know that if we go 2, 4, 6, 8, so if we have 4 divisions between this, we should have nice even spacing. To find the distance between these, we're going to just create a script. We're going to get a reference to our 2 parts. So we have our local start part. It's going to be script.parent and local end part is going to be part. At the moment it's .parent.bridgeEnd, but we might just change that. Move that one in there. Now it is start part.bridgeEnd. Okay. So we're going to get the distance between them, which is going to be 3, 2, 1. So we're going to get the distance between these 2 parts. And to get that, we need the positions. So start position, the end position, and then the distance is the end position minus the start position, no, the position, and we're going to get the magnitude of those. So we're taking 10.0.0, removing 0.0.0, returning just the vector 10, 0, 0, and we're getting the magnitude of that vector. So then, ideally, we want to get the points. We're also going to want the direction of that vector, which is going to be same again, the end position minus the start position. We're just going to create a table for these. So let's just do a quick loop over the number of divisions that we want. And the divisions that we want are going to be something that we code in. I'm going to say 5 divisions Actually, okay, we're going to be dividing it by 5, but we're going to say there's 4 divisions, because when we divide it, we're going to divide this by 5 to leave us with 1, 2, 3, 4 pieces in the middle, each with an equal gap of 2 between them. So I equals 1. We're going to go up to our number of divisions. Going to generate a point. We're going to start from our start position. And Roblox has a nice function for this. It's called lerp. It does linear interpretation along the line. You can just take the vector, do some maths with much the same parameters here, but this just makes it nice and tidy. We're going to go, so our goal here, as it's showing, is going to be our end position. And we're going to be, how many points along the way are we going to be doing? Well, we're going to be moving, for this point, we're going to be moving I, which is 1. Only how far are we going? We're going to be moving along this line, and we're going to be dividing it by our divisions, except our divisions is 4, because that's how many points we want along the way, but we're actually wanting to divide it into 5 parts. So let's just make it divisions plus 1. So we're going from our start position. The first point we're adding is 1 point along the line of our distance here. Divided by the number of divisions we have plus 1. We're going to insert that. Points, and we're going to insert this point that we just generated. Oh, and we're completing this. We missed a bracket up here, of course. Parentheses. All right, so that should generate in our points array our 1, 2, 3, 4 points along the line. Let's just print that. Points, and have a look to see if it goes. So we can see our table with 2, 4, 6, 8, which is exactly what we want. Nothing showing yet, but by doing this, it means that we can actually offset these in whatever way we want, because we can now move our parts around. Just give me a single part. And when we run it again, our linear interpolation function will generate the points evenly between those 2 coordinates, which makes life nice and easy. Let's just take that back down so we can now do something with these points. So as we move along, this is going to start getting more and more complicated. So let's start breaking it up into a module. I'm just going to come over here and create a module script. It's going to be our bridge module. Okay. And over here, we're going to bridge equals works. No, sorry, this is game replicated storage. Currently module script. No, we don't call it module script. Let's call it bridge. Okay. Now, what do we need in this function? Well, we're going to need our start part and our end part. But the rest of this will probably get pulled across into our bridge module. So we're going to create a function, create bridge points. We're going to take let's just say create bridge. Now, we are going to need our start part, and that is of type part. We're going to need our end part of type part. What else have we got? Divisions. Divisions is a number that should be, this is the bridge module, create bridge. So now we should be able to go local equals bridge, create bridge. We're passing our start part, end part, and our divisions. Not currently returning anything yet, so let's return points, and this should behave just as before with a little bit of refactoring done. There we go, exactly the same. That's good, makes life easier. Okay, now because we're going to start now dividing this up into different processes, we're going to be calculating these points separately. We're going to be then creating some parts to fill in these spaces. So let's just separate this function out a bit. We're going to make a local function, and this is going to be create points. And we're just going to move some of this up here. So again, we're going to need let's move these. And up here, then we just need the start position, end position, and divisions. We're going to create points without start, pause, end, position, and the number of divisions again. Let's just turn points and check that everything behaves as before. Yes, very good. So what are we going to do next? How about we fill in our gaps? So we're going to loop over the points that we've just got above. And we're going to create some new parts. and we'll set that dot parent. No. So I don't want millions of parts filling up my workspace. I'm going to set the parent to be this bridge start, which we're getting in here as our start part. So our size is going to be a new vector. And let's just stick with 1 to start with. And for the moment, we will set our part to be anchored. We'll change these shortly. And to make it a bit more readable, I like changing the name. And I will call it bridge I, which should give us the number 1, 2, 3, 4 at the moment. Bridge part I. And of course we need the position. So and that should be the current point. We're not returning anything now, so let's get rid of this and that. And we should be able to see some points being generated. There we are. We have 1, 2, 3, 4 points. We look over in our workspace. Under bridge start, we can see bridge part 1, 2, 3, 4. We should be able to see they all have the position correct: 2, 4, 6, and 8. Excellent. Now they are one assembly that theoretically we could move around together. And again, if we stop this and we do muck around with the location of one of our parts, when we run it again, we should see that they bridge that gap nicely. Of course, this part wasn't anchored, so it's fallen away. We will set that to be anchored now, because that could get problematic later. And of course, we'll anchor our start as well. That way, we will be able to make some points in space. Let's make it 10 high. Move the bridge back down to 10. And we'll keep it in one plane for the moment. We'll also move this up so that we can spawn up near our part. All right, let's see if we are now floating. There we are. We now have our first procedurally generated bridge that we can adjust easily. For example, we can make the gap bigger. And in our script, we just have to modify the number of divisions. We'll say that's now 10 divisions. And it automatically spreads it out for us exactly like we wanted. Okay, fantastic. What does this have to do with rope though? Now, what about if we make each of these parts that we're generating be connected not anchored, but connected to the previous part using some sort of constraint. So that's what we'll start working on next. So back into our create bridge. Now, this is going to get messy if we're doing all of our code for these down in here. So we're going to move the logic for creating the part up into a new function of its own, which will be a local function create new part. And the main thing we need to know for this at the moment is its position, which is vec3. And we are going to be taking this line up. And we might as well pass in I as well, which is just number. And we're going to be having a local part equals create new part. Passing in our point and our number. Here we need to return this part. And again, we'll be parenting it to the starting part down in this function, but this should do everything else we need. And by separating it up there, we can quickly just modify some parameters without having to go modify it in multiple places down here as this gets a bit more complex. Let's just check that still runs okay. All right. Now, if you have used constraints before, they're up here. We could try connecting each of these using lots of different constraints here, actually. I've played with springs. I didn't have a lot of luck because that takes a lot of balancing to get work, and it seems to be a lot of work on the physics engine. I had good luck with rod constraints and rope constraints as well. Let's start with rod, and I'll show you why I'm dividing things up into different functions here to let us switch between them. So to create a rod constraint between our first point and second point, it needs attachments for both of these points. At the moment, we didn't have any attachments. So what we're going to do is use the points that we've already generated to first of all be an attachment point, and then we will create our constraints between those. So before we start adding constraints between the objects that we're creating here in create new parts, we're going to need some attachment points. So we're going to have local start attachment. And it's going to be a new attachment. And it's going to be connected to our bridge start object up here, which is start part. Do the same thing for our N1 and attachment equals new attachment. This is our N part. Now for each of these points that we create, and we're creating the parts here, we're going to want to link them to the next or the previous part that we're creating. So for example, if we're creating our first part, So if I is 1, we're going to create a new constraint. Let's say it's a RodConstraint. You know what? Let's do what we did up here with create new part, local function, create new constraint. And we're kind of going to want its length, I think, is going to be something we're passing whichever type of constraint we use. So RopeConstraint. Length. What's our length going to be? Our length is going to be the distance. Oh, we're actually going to calculate that still. Let's leave that for a second. We'll return our constraint. Now, so this constraint, it's going to be attaching two things. The first thing it's going to be attaching to is our start attachment. Constraint attachment 1 is going to be a new attachment that we haven't created yet. Okay, so we're going to need another attachment here. So this is going to be local attachment is going to attachment. It's going to be connected to this part that we're just creating in this section. And fills in as this attachment. Okay. What else can we have? If it's not 1, we want our constraint to do another local constraint. And we're going to want this part to connect to our previous part. And we're going to want this attachment 1, to be the attachment that we just created. So what we're going to do here is set our previous part. Just set. And I guess that will be define that up there. We now have our previous part, and it's not the part itself that we want to attach to. It was just the first attachment, which we should be able to find. It's going to be the first child of class, and this is attachment. We still need to find the length of our constraint. So we want the distance, and we want to divide it by the divisions plus 1 like we worked out before, which should give us, for example, with our 10, we should then be dividing by 5, so our constraint length should be 2. So we'll be sending constraint length into these here. And if we unanchor this up here, the parts that we're creating, they should now be relying on these constraints. So let's just test and see if we haven't got it connected to the end yet. But let's just see what happens with these first ones, see if they link at all. No, they're certainly not anchored anymore. Let's see, we got our attachment, but it looks like I haven't anchored our constraints to anything. I can't see the constraints. So again, we probably want to set that constraint parent equals part. Let's just try that. Oh, and they are certainly doing something. Which is excellent. So we can see our rod length is 5, which is not what we wanted. Rod length is 5. Nope, something going wrong there. Actually, no, there's not, because we aren't doing the same settings that we had before. Let's change this back to 5 divisions just to make it easier again for us to visualize. And we'll move this one back to move this part back to 1010. Now with our, no, we wanted 4 divisions, which gives it 4 steps between, which divides it by 5. Let's just double check here. So bridge point 1, and its constraint is still 5, which it shouldn't be. It should be 10 divided by 5. Because we haven't actually used our length. Test again. There we go. That looks like what we need. Okay. To be done is add the constraint between the first part and the last part. So for this last one, we're going to be taking our previous part and we're going to be connecting it to constraint attachment 1 is going to be the end attachment that we created up here. And again, we need to parent this to end part. Now, what happened? They're all exactly the same. Well, that's because at the moment, they all are sitting out there with a constraint exactly the right distance between those two. So if we actually create this to be 2.5, and maybe the next one as well. Oh, there we go. They all start moving around. These ones still have the length of 2. These ones have 2.5, which gave it a little bit of room to move when I stepped on them, and they started coming out of position. So we were to end this and just say they were, we were going to say that the length of the constraint was length times 1.1, just to make it a fraction longer. See what that does. And there you are. They're all trooping away. And using the physics engine to hold them together. And there's a bit of movement there, but you can see in general, we can make a bridge as far as we like, just using constraints. Now, what if we want to go the next step and turn those blocks into making a simulated rope bridge, so it looks like a rope going between the two. Now we know that we do have rope constraints up in our constraints area here, which can make what looks like a rope there, but there's no actual way to interact with these constraint ropes. They do look pretty, and they do have a bit of curve. They're good for moving objects around, tying two things together, and as you walk around, the rope will keep things dragging behind you, etc. Or even replacing our rod constraints here. But if we want to be able to interact with the rope, we're going to have to do something a bit tricky, like hiding our objects here that we're creating, our parts, and showing the rope constraint instead of the parts. So let's start by making a few quick changes. What we're going to do is take our rod constraint and just change that to a rope constraint. Do much the same thing as we were doing before. We might make our parts a bit small. Let's say they're 0.2 bricks each. Let's set the transparency to be 0.8, so we can still sort of see them, but not focus on them. And then see what we'll set the now the rope constraint has a thickness available, and we'll set that to be a bit thicker so that it shows up a bit better. Let's see what we got. No, we can't see anything. Why is that? We may have to see. Set a visible option. Oh, there. There we go. We do need to set a visible option. Okay. I think that 0.5 is going to be possibly a bit big. There we go. We've got a rope. Now it's not letting us interact with it very much. Let's come back here and might just turn our transparency down again, so we can see the parts that it's creating there. So those little parts in there are actually smaller than the thickness of the rope, so we can't see it very well. Okay, we're going to want to be able to walk across it, so let's turn them up. We'll make them 1 brick wide. They don't have to be very tall. See what that does. Okay, so we kind of step. Whoa! That was impressive. So as you can see, the physics engine is doing a lot of work here because these parts can all rotate around the end of those constraints without having any sort of limits on the directions they can go. They can move together. We can see how big a problem this creates when we start making our divisions way higher. Say we've got 20 divisions over, and we'll move this out a bit further. They're all nicely stacked there so that we could theoretically run along it, but it's giving them a lot of hard work to do. Don't really want the physics engine to be replicating those constant movements all the way back, particularly if you're in a multiplayer game. So what we might try and do is lock down each of these objects so that each of our part can only, it can move in relation to the other parts, but it's going to have its origin locked. So in our constraints up here, we do have this align orientation option, and this stops it from rotating in certain directions. And that's what we're going to work with. So we're going to come back into our bridge script. We're going to, down in here, after we've created our part and hooked it up to the previous part, we're going to now create a new alignment constraint. And we're going to be passing it the attachment of the part that we've created for the current part. So let's come up here and we will create that's going to be attachment, which is an attachment. Now, this particular constraint is called align orientation. It's got lots of different things that need to be set. We're going to set its attachment 0 to be attachment. We are only using a single type of attachment for this. So we're going to be setting the constraint mode to an enum of checking my documentation here, oriental alignment mode, and this is one attachment because we're not basing it on the previous one, just the one that this particular part is attached to. We're going to set the align type. And this is setting it to, we're aligning all the axes and setting the rigidity. Okay, we're then returning this alignment constraint. Come down here to where we just created it. Set the alignment parent is going to be the part that we just created as well. Okay, quick test. Looking like we did before. Now when we run over them, they all stay aligned, no spinnings everywhere, and we have a nice wobbly and interactive rope. Just go back, hide our platforms, view again, and how pretty is that? Now I got to the end of creating those scripts and realized while they're really good, what would be even better is if we didn't have to adjust our settings by going into each of the scripts and modifying these settings in here. And what about if we could make the ropes longer or shorter, depending on how much we want them to be able to hang down? Well, let's have a look at how we can quickly implement those. We're going to start, I did duplicate these scripts, but let's just delete these extras. Now, what we're going to try doing is creating a couple of attributes. We're going to call the first one our rope length. This will be a number. And let's say it is 20. The other thing that we're going to try doing is setting our divisions. This is a number again. And let's start with that at 20 as well. We'll come into our script. And instead of setting our divisions here to be 20, we're going to take our start part and we're going to get attribute, and that attribute is called divisions. We're also going to be getting our rope length, and again taking our attribute, that is rope length, and now we're going to be passing in our rope length through to our create bridge function. Actually, before we do that, let's just double check that this get attribute divisions is working by making sure that we get the right number of parts back. So let's do let's see, we know we've got 20 divisions, we should be able to see down here, bridge part 20 is our last one, correct. And if we modify it down here, 10, there we go. So that makes it much easier for us to manipulate it on the fly. Of course, we can add in other things like our transparency or bridge size or visibility or all sorts of things, but we'll just start with some of these ones that would be useful overall. Now we're going to pass in our rope length. And down here where we calculated our lengths, where do we calculate our lengths? Constraint length here is currently distance over number of divisions plus 1. Okay. I guess the first thing we need to check is that, well, we're pulling in our rope length. So first of all, we want to check that our rope length is less than our distance. We want to bug out. We're going to warn rope length too short. Otherwise, we've got to set our constraint length to be, instead of the distance divided by divisions plus 1, we want it to be the rope length divided by divisions plus 1. And then up here, we're just going to set our constraint length to be length and not adding that extra in here. So let's have a look. We have our distance between the two parts, position, it's 22 and 0, so that should be minimum of 22. If we stick here with our rope length and we try creating this, it should fail for us. Yep, rope length too short. We'll bug out. If we set it to 22, it should let us create it, but it's going to be very tight. Yeah, lets us create it. Okay, so setting the rope length to be exactly that distance does work. However, if we set it now to be 28, that will, oh, that's an extra 6 meters. That's probably going to be too much. Well, 6 units, too much sag, maybe 25. And here we go. Yep, we had much more in there, and it's going to be hitting the ground. Now there's a quick way for you to duplicate the part and modify its properties just by changing the attributes without having to make any changes to the code as you go. Hope those extra tips were useful.